Mountain View, California. Thank you for joining us. I'm Pamela Harmon, the Director of Education here at the SETI Institute, and here are two of my colleagues. We are here this afternoon to talk to you about NASA Airborne Astronomy Ambassador Program, one of our flagship teacher professional development programs. So over to you, Dana and Coral. Tell the audience a little bit about yourselves.
I'm Dana Backman. I'm a professional astronomer and I'm the principal investigator lead of the AAA program.
And I am Coral Clark. I am one of the co-managers of the AAA program and have been in formal and informal education and professional development for almost 30 years.
Must have started as a child.
Yes, yes, I was 5.
So thumbs up and hearts and smiles for education here at the SETI Institute. So first off, Dana, tell the audience about the NASA Airborne Astronomy Program.
The Airborne Astronomy Ambassador Program is a NASA-funded program of professional development for high school science teachers that culminates, the professional development part culminates in flights on the SOFIA Airborne Observatory, and then the teachers teach a curriculum that we developed on electromagnetic spectrum and multi-wave astronomy in their classrooms, and then we have had professional evaluators check assess the impact on the student learning and student STEM engagement of the curriculum and the teacher's flight experience.
Oh, thank you, Dana. Coral, can you expand a little bit on the components of this program? Dana touched on most of them, if not all of them.
Well, this is a really unique program for educators. It's actually a blended model. We have an open application for qualified applicants that is judged by a peer-reviewed panel and recommended for participation. Once those teachers are selected, they're announced in January, and then they start one of the components of the program, which is a webinar series to go over the SOFIA specific content. And that is about 1 or 2 per month for about 6 months. They also do an online self-paced astronomy course so that we're sure that they can be conversant with the astrophysicists and other people that they would encounter during their flight week. Then they do an in-person 8-hour-long, day-long training, drinking from a fire hose, to get them to understand what it is like, what the curriculum components are. And then they do their flight week. So this is a unique, intense experience for the teachers that takes them from January all the way through their flight week, and then afterwards where they implement the 2-week curriculum with their students, and then they become part of our alumni, and we don't ever let them go.
Thank you. Dana, you mentioned NASA funding. Do you want to tell the audience how NASA funds this program?
Well, the NASA Science Mission Directorate, which it oversees all of the scientific research component of NASA, has a program which is called Science Activation, which is funding 24 education projects across the country, and this is one of those 24 programs that's been funded. This started at the start of 2016, and so we're reaching the end of the 4th year of the current funding cycle, but these were competitively selected projects using money allocated by the Science Mission Directorate specifically to support education of all sorts of education, public, informal education, formal education.
Thank you. So I also heard you mention evaluation. Coral, tell us about the evaluation process, or
Dana should do this.
Okay, Dana.
I should?
Yeah.
Oh, well, I can.
Yeah.
We had external evaluators, the West Ed company that is very experienced in all sorts of education evaluation and assessment, and they have helped us. They ran in the first 2 years of the current version of the program, the 2017 to 18 and 2018 to 19 school years. They ran a controlled experiment, a randomized controlled trial, comparing the performance on content learning of the students of teachers who had flown on SOFIA and were teaching our curriculum module to teachers who had not yet flown on SOFIA and were teaching the material in the traditional way that particular physical science topic is taught. And so they ran this experiment, and the teachers were randomly selected, so they were drawn from the same population. So it was truly a controlled experiment. And the students of the teachers who had flown on SOFIA and taught the curriculum that we wrote were substantial. There was a very large, statistically significant, at the 9 standard deviation level, performance difference between the students in the so-called treatment group and the students in the control group. And the teachers in the control group, then they got to fly the next year, so they didn't get left out. But anyway, the measurement was, we're told by the education experts that this size of a result, this significant result, is rare in the education field, where small results are just slightly significant results are the norm. But this is obviously a powerfully implemented, a very powerful effect on the students.
Yeah, that was a significant, as you said, finding, and collectively we have shared the joy in those results, because our challenge, as you said, was to measure student learning, and that is not easily done. And the fact that we had great results is just remarkable, and we like to celebrate that. So Coral, can you tell us a little bit more about the curriculum unit that the teachers implement in their classroom that led to these great evaluation findings?
I can do that. So it's a curricular unit. It's 2 weeks long. The teachers are all trained. They're provided materials. This is all national, next generation science standards, standardized design and aligned. And the critical thing about the next generation science standards, at least the way I think about it, is it shifts from just the content being blurted out at the students and having them memorize it, to actually experience it in the process of science. And so this, we call it three-dimensional unit, or three-dimensional learning. It means it's not just the content, it's also the science and engineering practices and cross-cutting concepts that tie everything together. The students are actually each day using hands-on materials. They're doing investigations. They on things that they would be learning anyway, about the concept of filters and light. What is light? What does a filter do? How can this be used to learn more about what it's emitting the light? How can we analyze that light using a spectroscope? That kind of thing. And then each day, their learning is tied back to actual SOFIA research. And then that's highlighted by the teacher's experience. And so they not only can share the content, but they can do it in a live, experiential, real-world way that makes the whole process of science investigation and research not esoteric. It makes it real for them. They realize how many people are involved in that process.
Go ahead.
Yeah, NASA understandably wanted us to demonstrate that this is having an impact on students. So we are offering a rich experience for the teachers, but the bottom line has to be, is this making students' science, technology, engineering, and math learning improved, and we demonstrated that.
And you're the astrophysicist, on the team, and how do you see, the connections that we wrote in the curriculum, to real astrophysics?
Well, it's interesting to me that astronomy, frontier astronomy, can be translated into a high school classroom, and that's not true of frontier math research or frontier chemistry research. You can't explain that in a high school classroom, but frontier research astronomy is still accessible to people in a high school curriculum. And we're not expecting the students to become astrophysicists. That's not the idea. We're expecting them to understand the electromagnetic spectrum, which is a very important basic concept in physics and physical science, because of the illustrations of SOFIA observing Pluto occultations and the heat pouring out of Jupiter's interior and the spectra of a supernova and so on and so forth as the examples.
And from the flight week, the immersion experience, any stories from teachers and their students that you want to share?
Well, I'm going to just share what we hear from every single teacher, which we don't have to. I used to try to drop this like CEO and you're going to find out this. I don't have to do that anymore, because every single one shares that they thought they knew how SOFIA operated and astrophysics research was done. And then they went down to flight week and they found out that it wasn't a group of 5 astrophysicists just sitting at a table. It was telescope operators and mission directors and people running the instrument and the people, aircraft mechanics, safety officers, people who had incredible, amazing journeys on their way to have that amazing, incredible job at NASA that many of them never in their wildest dreams thought they would actually end up having. These are real stories, the real process that they're able to bring back to their students. They also comment the importance of teamwork and problem solving. They get to see that usually in real life, especially the teamwork, but teamwork specifically of problem solving. Oh, what happens? The telescope isn't exactly operating correctly. How do they fix that on the fly? And they're just so impressed with how that functions, the support of one another, the respect that everybody has for one another.
The 3 of us take turns escorting the teachers, so we each of us have brought, well, must be about 50 teachers each by now on SOFIA over the course of 7 years.
It's the longest week you'll ever love. And so send us your questions. Let us know where you're located at and joining us from. How far away are you? And while you're sending some questions in and telling us where you're from, we'll go to some slides that'll help explain the story of the Ambassador Program.
Let me know when you have the first slide. Is it up?
It's up.
Okay.
Right.
That just, while the questions are coming in, that first slide shows in the center a picture of an early test flight of SOFIA with the door open, the telescope door open. So it's a 747. It was a commercial airliner bought by NASA and modified to carry a 100-inch telescope behind that rollback door. Normally, we don't open the door until we're at full altitude in the stratosphere, but this is one of the test flights, picture taken by a chase plane. And DLR on the tail, NASA and DLR on the tail. DLR is the German space agency. It's a 20% German project. And then down in the lower left, you see a group of our teachers. Actually, that's two combined groups of teachers eagerly looking at our dedicated education panel, which shows the status of the telescope and the airplane and so on. And then on the right is a picture of a group of teachers in front of the instrument flange where the scientific instrument camera or spectrograph is mounted, and the telescope is behind the bulkhead behind the teachers.
Because otherwise we'd all fly out. We don't want that to happen.
That, yeah.
We'd get fewer people applying to the program.
We have to continually assure people that this is not the NASA weightless aircraft, because we don't want to drop the telescope out the door. Yeah, not a good idea. You want to go to that another slide? Are we getting questions?
No questions yet,
Okay.
but we have a listener from Scotland. Hello.
This slide shows that we're a national program. The 50 states in the United States are incredibly varied. They are all full of wonderful, dedicated science teachers that are doing their part to train the next generation. And we are very proud to have a significant number of them having been represented and had teachers fly in our program. Currently, I believe I think it's actually, we're up to 32 states now, plus Washington, D.C. And this is showing for the entirety of the program, the current paradigm that we're in has somewhat less than this, about half as many have been in a previous paradigm. But we reach a lot of students, we impact a lot of teachers, and we're really thrilled to be part of this. They also, the pictures on this slide are also showing an ongoing option that people have. We get, sometimes we need tables at NASA events across the country with experts who have flown on a SOFIA plane as an educator presenting at tables, and we always have people eager to do that.
And I see that number, students reach to date 40,000. A teacher reaches 150 to 200 students a year, and some of them reach 150 students every semester. So the impact of providing professional development and a STEM identity for a teacher really, it has a far reach and a significant reach because of the number of students that they reach. I've got a couple of questions. One is, why did you put a telescope on the airplane?
That's a good question, isn't it? Because it's not an easy thing to do and to keep it stable. The aircraft carries the telescope above almost all the water vapor in the Earth's atmosphere, which allows us to look at the infrared part of the spectrum, which would otherwise be blocked by the water vapor. So even a high mountaintop observatory can't do the things that SOFIA can do, but SOFIA can do almost everything that a space telescope can do for quite a bit larger expense at a space telescope. So we're observing infrared, and that lets us look at stars and planets forming. It lets us look at interstellar chemistry. It lets us look through interstellar clouds to the black holes in the centers of galaxies and those sorts of things, which can basically can be best addressed by SOFIA and not a ground-based observatory.
Oh, thank you. Don't forget to share. If you're watching, don't forget to push this out to your friends on social media and share. We're going to talk a little bit more about the STEM immersion experience, or the Flight Week, and I see that some of the images that are coming up are on that. So go ahead and talk about
talk about the previous one. There we go.
So as we mentioned, it's Immersion Flight Week does have up to 2 overnight flights on SOFIA. Those are 10-hour flights. You have to get there 2 hours ahead of time to do a mission briefing. These are long days, but there's also a lot of other activities we do during the week, including visiting Antelope Valley area that's rich in space exploration history and other types of aero research. And we show them as much as we possibly can during that week. They also have an extended egress training, when you go on a plane and they say there's exits here and here and here. So this is kind of like that, only giving you the experience you really need for an hour to really be prepared if something went wrong, including donning an oxygen hood. So that image shows some people practicing with that equipment. We also look at the ground-based operations of SOFIA, including the mirror coating facility, that if the mirror the mirror will need to be recoated with aluminum. It's got a huge process where they strip the old coat and then they prepare it and then have to put it in this giant vat looking item, and then they recoat that. And then we also look at the instruments, and each one, the SOFIA is unique because its instruments can be upgraded and changed in just a few days. They can bring on new instruments with new technology every year, and that really helps advance the instrumentation technology.
Here are some pictures of our different groups of teachers on board. We have, as I said, a dedicated console was designed in at the start of the program, that SOFIA would have the capability to bring educators on board. And from there we monitor the telescope and so on. And to talk to the scientists about the data that are coming in, we go up and sit at their console with them, which is between us and where the telescope is. But anyway, we circulate around and the teachers talk to all of the personnel on board, usually about 20 people, doing all the tasks needed to get this all to work.
Okay, want to give a shout out to Roberto Teflik and the Guildford Queen who are listening in. Thanks for joining in. Have another question. How high does the observatory fly? What
45,000 feet, 14 kilometers, which is higher than a commercial flight, but not that much higher. 10% higher than a across the ocean commercial flight, something like that.
And another question. How long are the flights?
10 hours usually. We've had some 8-hour flights, but usually they're programming now as a 10-hour flight.
And during those flights, they usually look at anywhere between 6 to 12 targets and collect the minutes of data that the guest observers need to do the research.
There's a group of ambassadors recently, I think this is end of middle of October group, and you can see a better view of the instrument flange. The red item behind the two teachers in the middle, that's the forecast infrared camera built at Cornell University. So it's a big, very solid container with a can of liquid nitrogen, and inside of that a can of liquid helium, and inside of that is the camera chip held at 4 degrees Kelvin, which is 8 degrees above absolute 0 Fahrenheit.
I just wanted to point out this particular slide is showing 3 teachers from Las Vegas and 1 from a district, the William S. Hart district in Santa Clarita. We've had a great relationship with them for the last few years, and our hearts go out to them today. So giving you our support.
So you talked about this instrument. How many instruments are available for installation on SOFIA?
6 different instruments, cameras and spectrographs, which are then kept on for 2 or 3 week campaigns, because it's a 1 or 2 day affair to pull one off and put another one on. You don't do it during flight, and you don't do it in a few hours. So one instrument will be on for 3 weeks doing one particular type of science, and then another one will come on for a period of time. So that's the norm. Yeah, no switching instruments during flight.
And question in from Simon. What type of astronomical objects have been observed?
Every kind. I was on a flight a few weeks ago where we actually looked at the moon. That's the first time I'd been on a SOFIA flight where the moon was the target. So the moon, the planets, asteroids, stars, stars forming, stars at the end of their lives, interstellar clouds from which stars are forming, the black holes, supermassive black holes at the center of the galaxy, other galaxies, supernova remnants, comets, yep.
Asteroids.
You name it.
Not
We've
the
looked
sun,
at it.
not our sun. That's
SOFIA doesn't normally look at cosmologically distant objects because, well, for technical reasons, but we have done some of that, very distant high redshift galaxies. But so everything from the moon out to redshift of 4, which is 10 billion light years.
But not our sun.
Yeah.
But not the sun.
Not our sun. So it looks like we have one more slide to show. And returning from flight, we've all been there. As Dana mentioned, the 3 of us rotate being the flight facilitators, and it is early morning when we arrive. Very early morning. So we'll end the slides there. And remind everybody to visit our website, SETI.org, and if you are looking for more information about this program at SETI.org/AAA. And I'll throw the last question back to Dana and Coral. What if there's a teacher out there who wants to participate?
Well, what we would like you to do is go to our website, find out a little bit more details about what the program entails, and then there is a place where you can contact either one of us so that we can move forward with creating a partnership with your district. We want to ideally have partnerships with larger districts so that we can have increased and ongoing effects on the larger scale.
But any size district is possible.
Yes.
But we need to work with the district to for the selection of teachers.
So city.org/AAA. Visit our website, put thumbs up, hearts, and smiles. Share with your friends. If you're interested, go to the website, reach out, and if there's no more questions, we'll say thank you and we'll see you next time.